Next problem we have d square y divided by dx square plus y equal to 1 divided by 1 plus sin x. By writing this in the standard form, that is f of d into y, which is equal to pi of x, this will become d square plus 1 of y equal to 1 divided by 1 plus sin x. Therefore, the auxiliary equation is m square plus 1 equal to 0, and m equal to plus or minus I, and hence the complementary function becomes c1 cos x plus c2 sin x. So, which is in the form yc is equal to c1 y1 plus c2 y2. Now replace c1 and c2 by capital A and B. That will become y equal to a cos x plus b sin x, which will be the required complete solution. Here we have y1 is equal to cos x and y2 is equal to sin x. So y1 dash, that means differentiation of cos x is minus sin x, and y2 dash, that is differentiation of sin x is cos x. Therefore w is equal to y1 y2 dash minus y2 y1 dash. By substituting the values, we get w is equal to 1. Also we have pi of x is equal to 1 divided by 1 plus sin x. Now consider a dash is equal to minus y2 pi of x divided by w. So here y2 is sin x into pi of x means 1 divided by 1 plus sin x divided by w is equal to 1. So this will become minus sin x divided by 1 plus sin x. So which can be written as minus of 1 plus sin x minus 1 divided by 1 plus sin x. Here 1 minus 1, by adding those 1 minus 1 will become 0, and the numerator will become again sin x. So splitting the numerator, that will become minus of 1 plus sin x divided by 1 plus sin x minus 1 divided by 1 plus sin x. So which will be minus 1 plus 1 divided by 1 plus sin x. Therefore a dash is equal to minus 1 plus, again here conjugate of 1 plus sin x is 1 minus sin x. So multiply numerator and denominator by 1 minus sin x. So which will be a dash is equal to minus 1 plus 1 minus sin x divided by, here 1 plus sin x into 1 minus sin x, which is in the form a plus b into a minus b, so which is equal to a square minus b square. Therefore that will become 1 minus sin square x. Again 1 minus sin square x is cos square x. Therefore a dash is equal to minus 1 plus 1 minus sin x divided by cos square x, which is equal to minus 1 plus, again splitting the numerator, we get 1 divided by 1 plus cos square x, 1 divided by cos square x minus sin x divided by cos square x. Finally we get a dash is equal to minus 1 plus 1 by cos square x is secant square x minus sin x by cos square x, that will become secant x into tan x. On integration we obtain a is equal to integration of minus 1 plus secant square x minus secant x into tan x with respect to x plus k1. So a is equal to integration of minus 1 is minus x plus integration of secant square x is tan x, and integration of secant x into tan x is minus secant x plus k1. Now b dash, which is equal to y1 pi of x divided by w. Here y1 is cos x into 1 divided by 1 plus sin x divided by 1. So b dash is equal to cos x divided by 1 plus sin x. Again conjugate of 1 plus sin x is 1 minus sin x. So multiply numerator and denominator by 1 minus sin x. So in numerator we have cos x of 1 minus sin x, and in denominator again that will become a plus b into a minus b. So that is 1 minus sin square x. So 1 minus sin square x is cos square x. So finally b dash is equal to cos x of 1 minus sin x divided by cos square x. So here cos x, and in numerator we have cos x, and denominator we have cos square x. So if one cos x is get cancelled, we get b dash is equal to 1 minus sin x divided by cos x. So by splitting the numerator we get 1 by cos x minus sin x by cos x. So b dash becomes secant x minus tan x. On integration we obtain b is equal to integration of secant x minus tan x with respect to x plus k2. So integration of secant x minus tan x is log of secant x plus tan x minus log secant x. Here integration of secant x is log of secant x plus tan x, and integration of tan x is log secant x. That can also be written as log of secant x plus tan x divided by secant x. Therefore, by substituting a and b, we have y is equal to minus x plus tan x minus secant x plus k1 into cos x plus log of secant x plus tan x minus log secant x plus k2 into sin x. So this is the complete solution. Next problem. D square y by dx square minus 2 into dy by dx plus 2y equal to e power x to tan x. So in standard form, this given equation becomes d square minus 2d plus 2 of y equal to e power x into tan x. So this is in the form f of d into y equal to pi of x. Here f of d is d square minus 2d plus 2, and pi of x is e power x tan x. Auxiliary equation is m square minus 2m plus 2 equal to 0. So we cannot factorize this. So we use the equation minus b plus or minus square root of b square minus 4ac divided by 2a to find out the roots. Here a is equal to 1, b is equal to minus 2, and c equal to 2. Substitute the values in the equation. We find m is equal to 1 plus or minus I. Therefore, the complementary function becomes e power x of c1 cos x plus c2 sin x. So this is in the form c1 e power cos x, e power x cos x plus c2 e power x sin x. So which is in the form c1 y1 plus c2 y2. Now replace c1 and c2 by a and b. That will become y equal to a into e power x cos x plus b into e power x sin x, which will be the complete solution. So yeah, we have y1 is equal to e power x cos x and y2 is equal to e power x sin x. Therefore y1 dash becomes, so e power x into cos x, this is the product of two functions. So we have to use product rule. So first function is e power x and second function is cos x. So here y1 dash becomes e power x into cos x differentiation is minus x sin x plus, again keep second function cos x as it is, and differentiation of e power x is e power x. So in both the terms we have e power x common, Therefore, that will become e power x of cos x minus sin x. Now we have y2 which is equal to e power x into sin x. This is also product of two functions. Therefore, y2 dash is equal to e power x into differentiation of sin x is cos x plus sin x into differentiation of e power x is e power x. Again, e power x is common. Therefore, y2 dash is equal to e power x of cos x plus sin x. Therefore, w is equal to y1 y2 dash minus y2 y1 dash. By substituting the values of y1 y2 y1 dash y2 dash in the equation and solving this, we get w is equal to e power 2x. We also have pi of x is equal to e power x into tan x in the given problem. Now consider a dash is equal to minus y2 pi of x divided by w, which is equal to minus, here y2 is equal to e power x into sin x and pi of x is e power x into tan x divided by e power 2x. Therefore, in numerator we have minus e power 2x. E power x into e power x is e power 2x. Minus e power 2x into sin x into tan x can be written as sin x by cos x divided by e power 2x. So e power 2x and e power 2x get cancelled. So we have a dash is equal to minus sin square x by cos x. Again, sin square x can be written as 1 minus cos square x. Therefore, a dash is equal to minus of 1 minus cos square x by cos x. So again, splitting the numerator, we get a dash is equal to minus of 1 by cos x minus cos square x by cos x. That will become minus of cos x minus secant x minus cos x. On integration, we get a is equal to minus of integration secant x minus cos x with respect to x plus k1. Therefore, integration of cos x is sin x and integration of secant x is log of secant x plus tan x. Therefore, a is equal to sin x minus log of secant x plus tan x plus k1. Now consider b dash, which is equal to y1 pi of x divided by w. Here y1 is equal to e power x cos x and pi of x is e power x tan x divided by w is e power 2x. Again, e power x into e power x is e power 2x into cos x into again sin tan x is sin x by cos x divided by e power 2x. Here also e power 2x get cancelled and cos x also get cancelled. We get b dash is equal to sin x. So on integration, we obtain b is equal to integration of sin x into dx plus k2, which is equal to minus cos x plus k2. Integration of sin x is minus cos x. Now substitute the values a and b in the equation 1. We get y is equal to sin x minus log of secant x plus tan x plus k1 into e power x cos x plus of minus cos x plus k2 into e power x sin x. That is the complete solution. So next problem is d square plus 3d plus 2 of y, which is equal to e power x. So the given problem is in the standard form f of d into y equal to pi of x. Therefore, auxiliary equation is m square plus 3m plus 2 equal to 0. By solving this quadratic equation, we obtain m equal to minus 1 and minus 2. Therefore, the complementary function becomes c1 e power minus x plus c2 e power minus 2x, which is in the form c1 y1 plus c2 y2. Now replace c1 and c2 by a and b. The complementary function yc becomes y equal to a e power minus x plus b e power minus 2x, which is the complete solution, required complete solution. We have y1 is equal to e power minus x and y2 is equal to e power minus 2x. So differentiation of e power minus x is minus e power minus x, and differentiation of e power minus 2x is minus 2 into e power minus 2x. Therefore w is equal to y1 y2 dash minus y2 y1 dash. Substituting the values, we obtain w is equal to minus e power minus 3x. Now consider a dash is equal to minus y2 pi of x divided by w. So which is equal to minus into minus y2 is e power minus 2x and pi of x is e power x divided by w is minus e power minus 3x. So which will become e power x into e power x. On integration we obtain a is equal to integration of e power x into e power x with respect to x plus k1. Now take e power x is equal to t. Integration of e power x is e power x into dx is equal to integration. By differentiating we get e power x into dx is equal to dt. Therefore the above equation becomes a is equal to integration of e power x is t. So this becomes t into e power t with respect to t plus k1. So by using the I think there is some correction in this problem. It should be integration t into e power t. So therefore a becomes on integration of t into e power t. By using by parts, integration by parts, we obtain a is equal to t into e power t minus e power t plus k1. Now consider b dash is equal to y1 pi of x divided by w. So here y1 is e power minus x and pi of x is e power x divided by w is minus e power minus 3x. Therefore b dash is equal to minus e power 2x into e power x. On integration we obtain b is equal to minus of integration e power 2x into e power x to dx plus k2. Now again by taking e power x is equal to t and differentiating we obtain e power x into dx is equal to dt. Therefore the above equation becomes minus integration of here also we should have integration t square into e power t into dt. Some correction is there in this problem, so leave this problem. I will solve this problem in the classroom only.